All right, let's look at practice exam 1, problem number 6. All right, so we want to use the definition of continuity to determine if this piecewise defined function is continuous at x equals 2. All right, so the definition is, remember that limit of f of x as x approaches 2 has to be equal to f of 2, right? Then we can kind of split into three things. So we have to make sure that the limit, right, limit of f of x as x approaches 2 exists, right? And then we have to also make sure that the f of 2 is defined. And then on top of that, we have to make sure that those two values are the same. Can I just write it as a number 1 is equal to number 2? Right? So those are the three things that we need to make sure. Right? So let's look at number 1. So in order for the two-sided limit to exist, we have to make sure that left-hand limit and the right-hand limit gives us the same value. All right, so let's compute the left-hand limit. All right, so you have a limit of f of x as x approaches 2 from the left. All right, so if x is approaching 2 from the left, which means that the x is usually starting out with something smaller than 2, right? So we know that we're going to have to use the top formula. So you have 3 plus x, right? Because this is defined when x is less than or equal to 2, right? But in this case, we just need to plug in x equals 2. So you're going to have 3 plus, right? And x is approaching 2. Right, so the left-hand limit is going to be 5. Right, so let's do the right-hand limit. So you have a limit of f of x as x approaches 2 from the right. Right, so you have a limit as x approaches 2 from the right. Right, so if x is approaching 2 from the right, so x is going to start from a bigger than 2, so we're going to have to use the bottom formula. So you have x squared, right, plus 1, right? Then again, you just plug in 2, so you have a 2 squared plus 1. So it's going to be 4 plus 1. So this gives you 5, right? Since the left-hand limit is equal to the right-hand limit, we know that the limit exists. And also, we know that this is equal to 5, right? So I'll just write that in here. All right. How about f of 2? All right, so f of 2, so when x equals 2, you see that 2 is included in here, so we have to use the top formula. Then you have f of 2 is equal to, right, formula is 3 plus x, so you have a 3, and x is 2 in this case, so this is equal to 5. So, of course, the f of 2 in this case is defined, and the value is equal to 5. Right? So since both limit and the f of 2 give you 5, so we know that the number 1 is equal to number 2. So therefore, it satisfies the definition of continuity at x equals 2. Right? So therefore, we know that f is continuous at x equals 2. All right? That's it. I hope that this was clear.